everybody. I hope you are doing well. Now we are going to continue our lessons about operation of complex numbers in polar form. So let's give two complex numbers, Z1. So we have Z1, which is equal to R1 cosine theta 1 plus I sin theta 1. We have also ZD2, which is equal to modulus 2 cosine theta 2 plus I sin theta 2. We are going to start about the multiplication. So what will we have if we take Z1 times ZD2? Z1 times ZD2 will be equal to modulus 1 cosine theta plus I sin theta 1 times R2 cosine theta 2 plus I sin theta 2. Because we are going to move about multiplication, so here modulus 1 will be multiplied by modulus 2. Then I'm going to take cosine theta 1 is going to multiply through this whole side, cosine theta 1 times cosine theta 2 plus I sin theta 2, then plus I sin theta 2 times the same as here. Here we have is I sin theta 1 times cosine theta 2 plus I sin theta 2. So the next, what we are going to do here, we still have our modulus 1 times modulus 2, R1 times R2. Our cosine, if it multiplied inside here, we will have cosine theta 1 cosine theta 2 plus I sin theta 2 cosine theta 1. Then we move here plus I sin theta 1 multiplied through this next one, we have I sin theta 1 cosine theta 2. Then this one times this term here we have I squared sin theta 1 sin theta 2. So you see what we are going to have here. We are going to put real part together and the imaginary part together. We have R1 times R2. This one is cosine theta 1 cosine theta 2. Here we have I squared will become negative, so minus sin theta 1 sin theta 2. Then plus I, with this term we have sin theta 2 cosine theta 1 plus sin theta 1 cosine theta 2. So we know that cosine A plus B is equal to cosine A cosine B minus sin A sin B. While sin A plus sin B is equal to sin A cosine B plus sin B cosine A. So using those two factors from there above, we have modulus 1 times modulus 2. This one from here will become cosine of theta 1 plus theta 2 plus I sine of theta 1 plus sine theta 2. So simply through multiplication, ZD1 times ZD2, or product of two complex numbers, is equal to the product of their modulus times cosine of theta 1 plus theta theta 2 plus I sine theta 1 plus sine theta 2. So that is how we are dealing with multiplication of two complex numbers in polar form. Here it will help us. Here, when we have z1 over z2, I'm talking about division of complex number in polar form. We are not going to demonstrate. Really shortly, we have R1 over R2 modulus 1 over modulus 2 times cosine of theta 1 minus cosine theta 2 plus I sine theta 1 minus sine theta 2. So simply, that is the multiplication and the division of complex number in polar form. So let's try to do an activity. Let's z is equal to 1 plus I. Then we have w, which is equal to square root of 3 plus I. So determine the product of z1 times w. So what are we going to do first? We are going to find modulus and the argument of the first complex number. The modulus of this complex number will be equal to square root of 1 plus 1, which will be equal to square root of 2. So the argument of z, when we see this complex number, you see that is located in the first quadrant. So our argument will be equal to arctan of y over x, where y is 1, even x is 1. So arctan of 1 is equal to pi over 4. Then I'm going to find the modulus of complex number w, which is square root of 3 plus I. So each modulus will be equal to square root of a squared plus b squared. A squared is the square root of 3. If you square the square root of 3, we say with 3. Then plus 1, where we have square root of 4, which will be equal to 2. So the argument of z, both they are located in the first quadrant. It is the inverse of that one. Arctan of 1 over square root of 3, which will give us pi over 6. So we get the modulus, we get even the argument. What we say with it is to find the product of z times w. So z times w, we have found that it is the R1 times the R2 cosine of theta 1 plus theta 2 plus I sine theta 1 plus theta 2. So what will we have here? So modulus 1 is the square root of 2, modulus 2 is 2. We have 2 square root of 2 cosine theta 1, we have pi over 4 plus argument of z2 is pi over 6. So this is w. Then plus I sine pi over 4 plus pi over 6. We have 2 square root of 2. Pi over 4 plus pi over 6, we have cosine. Factor is 12. 12 we divide by 4, we say the 3 times pi, we have 3 pi. Plus 12 we divide by 6, we get 2 times pi, it is 2 pi. Plus I sine the same 12, we have 3 pi here plus 2 pi. Finally, our z times w will be equal to 2 square root of 2 cosine 5 pi over 12 plus I sine 5 pi over 12. All our z times w can be equal to 2 square root of 2. C is 5 pi over 12. You see here the short notation of cosine plus I sine of that angle. We have 2 square root of 2 square root of 2 C is 5 pi over 12. That is one way. Alternatively, or another way, we can find the Cartesian form of that product. We have z times w. In Cartesian form, we have square root of 3 plus I times 1 plus I. We are going to find their product in Cartesian form, then finally we find it in trigonometric form or in polar form. So we know how we deal with multiplication. We will have square root of 3 plus I square root of 3 plus I squared, which will give us square root of 3 plus I square root of 3 plus I negative 1. So by putting real part together and the imaginary part together, z times w will be equal to square root of 3 minus 1 plus I square root of 3 plus 1. So this is the Cartesian form of the product of z1 times z2. We are going to find the modulus of this product of z1 times z2. So the modulus will be equal to square root of 3 minus 1 squared. We consider this one as A and we consider this one as B, plus square root of 3 plus 1 squared. So from this step, our modulus will be equal to what? We are still having the square root. We are going to expand what we have inside. Square root of 3 squared, we will have 3 minus 2 square root of 3 plus 1. We move for the next factor we have plus 3 here plus 2 square root of 3, then plus 1. Here we simplify this and that, and we stay with square root of 8, which will give us 2 square root of 2. That is the modulus of z times w. Now we are going to find it in a trigonometric form or in polar form. But before, we have to find the argument of this one in Cartesian form. So if we check the way our complex number about A and B, we have a tan or tan inverse of square root of 3 plus 1 over square root of 3 minus 1. So the tan inverse of square root of 3 plus 1 over square root of 3 minus 1 will be equal to 5 pi over 12. Exactly, I reach or I get the argument of that one. So finally, z times w in polar form will be equal to the modulus we have found, 2 square root of 2 cosine of the angle we get. It is 5 pi over 12 plus I sine 5 pi over 12. So by comparing with what we have again here, we have 2 square root of 2. C is 5 pi over 12. So you see the value of the answer is still the same. So what will be happen? Z over W. As you have seen, we divide their modulus, then we have cosine of theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Then both we have it. So what will we have? Z over W. What will we have? We will have 2 over square root of 2 cosine of pi over 4 minus pi over 6 plus I sine pi over 4 minus pi over 6. So what will we have here? We will have 2 square root of 2 over 2 cosine. We have 12. Here we have 3 pi minus 2 pi plus I sine 12. Here we have 3 pi minus 2 pi. So finally what we have? We have square root of 2 cosine pi over 12 plus I sine pi over 12. So that is how we did about multiplication and division of a complex number in polar form. So we have some property that we have to know. Normally, arguments of our amplitude of ZD1 times ZD2 can be equal to arguments of ZD1 plus argument of ZD2. So if we have the argument of ZD1 over the second complex number, this is the same as argument of ZD1 minus the argument of ZD2. Also, we may have the argument of a complex number 1 over ZD1. This is the same as negative argument of that complex number. So here is 1. So also, we may have the argument of a complex number z power n. This is the same as n argument of that complex number z. So simply that is how we did about operation of complex number in polar form, including multiplication and division. So thank you so much.